Here with Michael Napoleon, started in the golf world, but heads up the baseball division at VELO Sports, and Dr. Tyler Standifird, Associate Professor of Biomechanics at Utah Valley University, and is a consultant for VELO Sports and Super Speed Golf. What did I miss on that? Did I miss anything?
Yeah, that works great for me, Ryan. Good job.
Okay.
Great to be here.
Can you guys both go through your path a little bit before we get into this, just so people know kind of your where you started, how you got to where you're at?
Go for it, Tyler.
Yeah, so I got my PhD in biomechanics at the University of Tennessee in Knoxville. Always passionate about sports. Had to do most of my research on total knee replacements in my PhD days, but that paid the bills, so I said yes. And ended up at Utah Valley University and have slowly kind of built up a sports performance biomechanics lab there where I've worked with our basketball teams, volleyball teams, and then over the past 2-3 years have gone a lot into our rotational sports teams. So done a lot of research related to how golfers utilize the ground and to generate force and speed, how training can influence those things. And now just this summer hooked up with our coach at Utah Valley University, Coach Eddie Smith, and been working with the baseball team a bunch, looking at training aspects and all the different stuff. So it's a fun world to be in right now in the world of kind of sports biomechanics. And I'm loving every minute of it.
Michael, go ahead.
No, thank you. So again, I'm a golf coach by trade. Ran a big golf academy in Chicago for a long time called Catalyst Golf Performance. At this point, I would consider myself more of a specialist in speed and power coaching, and that has definitely moved past just golf, but actually into a number of other sports, including baseball and tennis, a little bit of hockey. It's interesting, even back at our golf academy in Chicago, we used to do physical assessments and 3D motion capture analysis for Justin Stone before he started working for the Cubs. So we probably had 50 to 80 of his players that would come through our facility because we had the really expensive motion capture systems and all of the different things that we would do. And I know he's been a pioneer on that side in the baseball world, but a lot of the stuff that he presents is actually data that we captured at our golf academy. So that's a really fun kind of parallel here. But, as we were doing that, we had all the best technology. We had a lot of really smart professionals in both the, golf coaching, but also the fitness and rehab world. And that got us into looking at things that really worked to help people improve speed. We actually sponsored a World Long Drive team for about 2 years, had 5 of the top 20 in the world World Long Drive players. Obviously, a lot of those players used to be baseball players. So we got very involved with a lot of those athletes. We started Super Speed Golf in 2014, which is kind of the industry leader in that space as far as, golf swing speed training. About 2017, we launched our baseball products under the brand Super Speed Slugger, which caught on, really fast, actually. We had about, third to a half of Major League Baseball using those with their teams, a lot of different collegiate teams using those. Our initial designs on that product, we always wanted to improve. And, we also wanted to get a little bit more of a footprint into the baseball world. And that's where we rebranded into VELO Sports for all of our baseball products that we now have at market.
How did you two get connected then for VELO Sports? Obviously, you're both specialists in what you get. How did you two get connected for VELO Sports?
Yeah,
Tyler actually found us, right?
Yeah, this is a fun story, right? It was kind of COVID. I was looking for stuff to research, passionate golfer, sent an email just to their info@superspeedgolf.com, and they're like, who is this crazy guy? And we worked together on one small project, and that was, now almost 4 years ago, and it's been fun. Mike and Kyle, they're so interested in the science and the data of how this stuff works. So I'm fortunate to fall in with a group that says, we know it works, but we want to know how and why so we can make it better. So they just have given me the green light for 4 years to research everything under the sun.
And go ahead, Mike. Go ahead.
No, I think it's been a really interesting, journey for us overall because, again, we come from that very highly specialized coaching world. I mean, we were some of the first using advanced 3D motion capture systems and all the different launch monitors and ground force systems and all of those different things to try to make us better coaches. And that was kind of where we started. And golf was kind of ahead of that game back in in 2010 to 2018. I think baseball's catching up rapidly right now, which is really, really cool. But we already had that background in looking at a lot of the evidence-based things that we'll do in coaching. And that kind of sets us apart now that we're mainly a digital coaching, digital training aid type company. We still highly vet every single thing that we put out, all the different programs and protocols. And that's really where Tyler's been instrumental, because he's able to actually do university level research studies on the different training programs that we might have, or testing out new products that we have. So it's helped us just streamline and make everything we do more effective and more efficient.
And that was my next question. Why do you feel like golf and track and field have always been ahead of baseball and technology and research standpoint? Because it has. I mean, you can look at everything that baseball adopts usually comes from golf or track and field in the initial. And Tyler, you were at East Tennessee State, which is a great place for track and field research.
Yeah, it's funny, Ryan, is I've worked with baseball players more recently, and I don't know if this is true for all baseball players, but they are a superstitious bunch, right? I mean, they're even as I've collected data and shown things, they're kind of like, well, yeah, but my tape is black on my bat, and I don't know if I can even swing that thing that's wide. And so sometimes I think it's just the inroads of getting in and helping them understand some of the data. I think the way the technology has gone, right? So even if something like TrackMan for golf, which measures what a golf club and a golf ball is doing, that grew really big. And now you're starting to see TrackMan for baseball start to pop up. And so I think the metrics we can measure are getting better. Again, I'm fortunate at UVU, our coach there in baseball, he is a data junkie.
Yeah. Coach Smith and I go way back. That was in my later on. Eddie and I go way back to the Iowa days, way back.
Yeah, he is a guy that he's like, Tyler, I almost think too analytically, I have to step back a little bit. And so I also think, it's about educating these coaches too, to help them kind of see the benefit. You're trying to get a coach who's in charge of a big team versus maybe one golfer or a coach with just a few, right?
Right, and I really think it has to do with how the industry is structured. So like in the golf industry, the big equipment companies run the show. Like they are pushing the envelope on technology all the time. And therefore it allows a lot of these technology companies an easy inroad, because like TrackMan has an easy time in the world of golf to sell, 300 TrackMans at a time to Titleist and TaylorMade and these companies that all want them and want their tech reps to have them and that kind of thing. Like I feel like baseball is a little different. It's not as driven by, the equipment companies still drive technology, but, baseball bats are pretty similar to what they've been, for a long time. And there is some really cool new stuff happening now, but I just think that part of it drives the industry a little differently.
And I like that baseball's getting caught up, but obviously training for track and field, training for golf, the practice portion of that is a little bit different because there's not as much of a team component with it. But I do like the fact that baseball's starting to get caught up with that. It's just golf's an individual sport. Track and field are individual sports. You have those team components when they're playing on their teams, but baseball's a little bit different. But I like the fact from a training standpoint that baseball's starting to get caught up.
I think it's interesting too, and I think this is really key to what we are trying to do and our team's trying to do is, we're not trying to make things more complicated just because there's launch monitors and all this data. Like, I do think that data overload is a very bad thing for players in any sport. So that's not really the goal. Like, we like the data because it allows us to be very precise in what we recommend and what we then know what the effects of those different training protocols and whatnot are going to be. So our goal with that technology is really to make it easier and more effective for the player. I think that's a key point to what we're trying to do. And
you guys gave me a list of topics, which I appreciate, but let's get into overload, underload, because we were doing this in the 90s, but it was more off feel and more conditioning, honestly. Once we got done with fall ball, we would get into our overload, underload stuff, but it was basically for reps and add on weight, and it's come so far from that. So I'm glad that was the first topic that we could talk about.
Yeah, we could probably talk about this for the next 3 days if you'd like to. Like, we have more research on overload, underload training than probably anyone else in the world. I'll start here. First of all, we like to call it overspeed training. And the reason we like to call it that is because it's a lot more descriptive of what's actually happening physiologically for the player. So, the traditional concept of overload underload training, and this comes back from like Coupe de Rennes and all of the different studies that he did, and a lot of your different Tom House stuff, who, we've interacted with all of those people in our time. And, I just think we've tried to make it more efficient. So first of all, what really happens here is it's a neurological training. So this training is not about getting stronger. It's not really about affecting the muscles of the body. It's more about affecting the brain's control over the body. So we like to think of overspeed training as just making your body move faster than normal during a motor pattern that it already knows, in this case, the baseball swing, in order to kind of reprogram the normal reaction speed of the body. And you do that not necessarily by getting heavier items. It's actually the lighter stuff is way more important. So you'll notice that in all of our training protocols, you always start with that base bat and that VELO set, which is 20% lighter than the player's game bat. The first sleeve adds back another 10%, so you're still 10% lighter than the game bat, and that second stack sleeve makes that bat 5% heavier than the game bat. Now, we'll actually see during that training protocol, every single swing that player makes is going to be faster than their normal game bat speed. So that's a major difference of what we've found to be more effective than the traditional idea of, okay, we're going to swing something lighter, and then we're going to swing our game bat, and then we're going to swing something like 20% heavier or so. We've always found that the heavy side is less important. And it's also not going to have lasting permanency to the effect of the training. To the point that if you do too much heavy training, you'll actually slow yourself down on the same topic.
And Tyler, obviously you've done research on this piece too. So it's better to start under first and then build up rather than going heavier first to start.
Yeah, because the key is, right, we're trying to help in any kind of overspeed training, we're trying to help that player move faster than what they currently do, right? Lift that governor off the speed. And that's why it's like when you take away some resistance, get them moving fast, and then reintroduce it, the speeds just jump. Versus, the way that the heavier ones can be really effective at, I think, training some mechanics of the movement, some of the things they might be working on the swing, because they can sense that weight a lot. But if you introduce that first in an overspeed training session, speeds drop, and then you're not training the body to move faster, which is the whole goal of the overspeed training system.
Yeah, any player can go do this little simple test. Most every baseball player's got a donut, right? Like, the old adage here in baseball, and tell me if I'm wrong here, but is that I'm going to throw the donut on, I'm going to swing a whole bunch of times, I'm going to take it off, the bat's going to feel super light, and then I'm going to go faster. The problem is when you actually do the research on this, if you just do the heavy, even though the bat feels lighter when you go back, you're actually going to be swinging significantly slower than even your starting bat speed. So it's kind of the opposite effect there. You got to move faster first and then sort of solidify those faster speeds with a little more resistance.
I used to make guys swing a lighter fungo on deck. One
Awesome.
aluminum fungos. It cleaned guys up. Like I was in your camp on that. I had no data to back that up at all. It was a feel thing from coaching, and so guys that were struggling, I would make them swing one of the lighter aluminum fungos on deck.
Well, we have an on-deck protocol coming out with the VELO system very soon. So we have a few protocols already launched on the website. We do have a mobile app that we're going to be working on here real soon, and hopefully we're going to have that out early next year. But then you're going to see the full kind of the full spectrum of what we're going to be doing. We're going to have stuff in there for not only just overspeed training, but we'll have warm-up protocols, we'll have ground mechanics protocols, sequencing protocols, bat delivery protocol, all kinds of different stuff that we can work on to help players get more speed and more efficiency.
And same thing with dry swings and live ball then too?
Yeah, so this is another big topic. So we've done a lot of research here too. So bat speed training is best done completely with dry swings. The actual speed training we always do with dry swings, and then we'll do what we call like exit VELO application protocols in baseball. So we'll then do a specific protocol that does introduce hitting a ball, trying to apply those speeds that we've gained during the bat speed training, in the cage hitting live balls.
Tyler,
I think that's the thing. Yeah, I would just add to that, Ryan. I think sometimes with this overspeed training, again, dry versus with a ball, a lot of times I think these rotational athletes have this question of like, well, yeah, if I'm not swinging at something or a ball, what's going to happen then to the mechanics when I get in there and am trying to actively hit a ball? And again, my research has shown that those mechanics, if anything, they're actually getting cleaned up. I think you kind of mentioned that with your on-deck practices. And so as some of these baseball players I'm starting to work with now, it's fun to get these texts where they say, man, my swing just feels a lot better. And it's like, well, yeah, when you do overspeed training, you just get so much more efficient. You're sequencing things better. Even though you're not hitting the ball, then you have to actually hit the ball, and things are just so much more improved.
Yeah, this part's even more important, Ryan, in baseball than it is in golf and in sport. Like, so golf, it's like we're always hitting it off a tee, right? So like we basically have a static, piece there. But, we've done studies that have found definitively that, like, the better the player, the less they're going to change anything when the ball's there. Because all they're thinking about is getting the ball, as far as they can or out. Like, in baseball, the skill element and the timing elements of being able to hit the ball are almost impossible to overcome when you're really trying to introduce something like swinging the bat 8 miles an hour faster, right? So again, we kind of start with the training, get the speeds up, then we apply those speeds to the skill elements of the sport after that, get in the cage.
And that's the difference between the training piece of it and the competitive piece of it too. Is there such a thing as too light or too heavy?
Oh, yeah. Tyler, why don't you get into that one?
Yeah, I think for sure, right? I think, again, and I've been able to research this stuff, right? Like Mike said, I'm fortunate to be able to do that. And so the key really is that as you start getting really, really light or really heavy away from those weights of that implement you're swinging, again, be it a golf club or a baseball bat, that's when mechanics can potentially start to change. Right? That's when all of a sudden you get that baseball player, that really, really light bat, and instead of creating that load and then getting that explosion off of their front leg, all of a sudden, right, they're just whipping things through with their arms. They're not firing those hips through. And so it's just, again, and my research, showed that, right? And so that's where I think VELO's done a really great job of dialing in these weights, dialing in these lengths to make sure that we're getting the benefit of the overspeed, but we're not leaking in and getting these improper mechanics during the speed training.
Yeah, if we get really technical here, Ryan, like it's all about the MOI of the implement we're swinging, right? So that would be effectively the measurement of how much resistance that bat has. And that can be affected by the weight of the bat, the balance point of the bat, a couple other different variables. So we've found that we want to be, we want to have this like range of MOI for the first
what's
bat.
MOI? Because we have a wide range of listeners. What does MOI stand for?
Go ahead, Tyler. You can do that.
It's the moment of inertia.
Okay.
Yeah, if you go back to the Bill Nye science days, right, inertia is a property of matter. It's basically the idea that it's the resistance of that object to an angular change of motion. So more inertia, more resistance, right? And so an angular version we call inertia, and linear, it would just be how big something is. Big rocks are harder to push than small rocks. High inertia bats are tougher to swing than low inertia bats.
Yeah, the heavier the bat and the further the balance point is toward the end of the bat, the more MOI it has, right? The lighter the bat and the closer that is to the handle, the lighter that bat is to swing. So that's a key point. But there's a range, right, of how light we want that bat to be, lighter than that player's game bat for optimal results. It's not exactly 20%. It's really like 26 to about 18% for the first bat. And the second one, we want it to be within like 14% and 8%. And then the heavy one, we want it to be no more than like 7% heavy, and down to even 1 to 2% heavy is fine. The heavy side is way more important. If we get too heavy, we're going to lose the ability. When you get too much resistance, you effectively can't swing it as fast as you were before, and we kind of lose the effect of the training. And that's why
when I was making players use a 60-ounce Pro Cut bat, that wasn't right.
Well, I mean, it may have been great for teaching ground force and sequencing, okay? Could have been great for ground force and sequencing, but it's not a speed training.
For sure. What are optimal reps for this within the program?
Not many. So really, it's not a ton of reps that we like to do. All of our protocols actually do 3 reps per drill per side. Now, a cool part here is we actually do make all players do this both on the dominant and non-dominant side. And we have seen some absolute huge benefits for that. I mean, in a bunch of different, but Tyler's actually writing a paper right now, kind of looking over all the different scholarly research that's been done on non-dominant training, but that's a huge thing. So reps low, because again, it's not about how many, this isn't like weightlifting where, doing 30 reps with a light weight's going to help endurance of the muscles. We're trying to max out the speed. So each one of those reps, even though there aren't that many of them in the training protocol, are max intensity. And that makes, I think our level 1 protocol has like 39 total swings, half of those on the dominant side, half on the non-dominant side. And I can tell you that I have seen some incredibly good athletes, Major League Baseball athletes, basically on the ground if they're doing that protocol right after 39 swings.
And I'll just add, Ryan, again, I come from a world of exercise science, right? So this idea of velocity-based training is now starting to even leak over into something as simple as a squat or a bench press, where instead of being so interested in the weight you're moving, you start saying, well, how fast am I moving it? And they'll put sensors on those bars.
The Tendo units.
The Tendo units, exactly, right? And that's kind of what this is kind of trying to do. Again, we have a radar that allows you to measure those air swings. And so you can start to see that stimulus of, hey, if I can swing this lightest bat 100 miles per hour, and then 8 swings, 10 swings later, or the next morning or 2 days later, I haven't slept well, I've trained too hard, etc., I'm only swinging at 91, all of a sudden we have a really good idea that we're overtraining, that we're fatigued, we need to step back. Less is more with speed training, right? It's not the opposite way around.
And that's a track and field thing too, especially with rest intervals too, as far as that. And like how does the athlete need to feel refreshed before the next round, or how does that work with rest intervals?
We recommend 3 days a week with a full day off in between at a minimum. And we've tested that exhaustively, and we really haven't. We want to do at least that's a good number. With some athletes that are doing a lot of high performance speed training outside of like the actual movement of the swing, we can even get away with a little less. Our typical question that we get is, hey, I'm getting great results with this, I want to do it more. And we're always like, hold on, like, no, less is more on this. We have a horrible time with that, especially with high level players. They always want to, they think if they do double the amount, they get better results. And you'll actually find that if you do twice as much of this and do it every day, your actual speed gains over time will be less because you aren't able to maintain the same intensity during each session.
And then what are you seeing with the transfers as far as bat speed into exit velocity?
Yeah, I mean, we've seen a number of really good things. So our average that we see in the studies we've done so far is about a 6% bat speed jump during our first 6 to 8 weeks of training. Exit velocity actually stays about that same. So it stays right in that around 6% range for baseball, which is, I mean, a huge number when you start to talk about. These are anywhere from, this is across the board too. We've done this with junior athletes. We've done this with collegiate players. I mean, I've seen this with players that are starting with bat speeds in the 80s, getting into the high 80s, low 90s. It's significant.
Love it. All right, let's get into ground forces. And by the way, Mike, I had Stoney on the podcast during COVID, and we talked about ground force reaction, ground force plates.
Yeah.
But he didn't give you any credit on that, so I have to give Stoney the business on that.
It's okay. He probably got into most of the ground force stuff after we dealt with. So, again, I left Chicago in 2017, so that would have been the last stuff I was doing with Justin. Most of what I did with him was just 3D motion capture, so that's okay. If he's moving into the ground force stuff, that's where he should be.
And this was a while ago. I asked him about in-game. I know it's probably maybe impossible to try to find a way to get it in the dirt with cleats, because I just wanted to see, does it make a difference from an anxiety, energy level standpoint? Because obviously with a live ball coming at you, it's probably not the same because mechanics are mechanics, but does it make a difference when they've got cleats on?
We just did
I don't think anybody's been able to do it.
Yeah,
we just did a huge study on the golf side looking at different types of golf shoes, and does that matter?
Yeah.
And I can tell you that it 100% matters. Like your ability the connection and friction you have with the ground makes a huge difference on your ability to be able to generate ground force.
Yeah.
And I think to that point too, Ryan, like the idea, I invite athletes into my highly controlled laboratory, right? Again, whether that's a golfer, a baseball player, a basketball player. And again, I'm always trying to figure out what's the way to recreate these things that they would see out on the field. In fact, when biomechanics really started a lot in running, you mentioned track and field, they did a lot of studies measuring outdoor to indoor on a treadmill and found very little differences between the two of them. Like you said, right? Like we need those kind of studies. And now that we have more advanced motion capture systems, markerless motion capture, force plates that can actually travel and are portable and run through iPads, now we have the capacity to say, gosh, let's stick some force plates in a ground The only issue right now, Ryan, what's tough with force plates is the dirt. Yeah. Right? It's the idea of getting that in there and on there and kind of how does that work? And we did some stuff in Tennessee on turf where we were actually able to secure different turfs, even like grass, to our force plates and look at cutting mechanics and things like that. And so I hope we see that type of stuff down the road.
I mean, what are you seeing out of the elite swings, baseball swings out there as far as ground force, how it works through the entire swing?
Well, this is another 2-day webinar.
I know. Well, we'll have to have you back, but I mean, we got time. But I just want to throw these out because this is obviously for our listeners, but also for me too. Because
can you give me a
science background?
First, Tyler?
I came from a science background, and so I'm always intrigued by research. In any field, I'm always intrigued by research.
All right, Ryan. Let me give you the 30,000-foot view here on what we see. Okay, so there's some really important stuff that we look at with ground force. Number one, obviously, we're going to look at how much ground force is produced in a few different areas. We're going to look at how much of that force is going to produce laterally. So, specific, kind of in a basic sense, how much are we pushing, away so that we can be propelled toward the pitcher, essentially, with the trail foot. We're looking at that a lot. We're looking at how do the 2 feet work together, the lead foot pushing toward the plate, the back foot pushing away to create rotational torque, and really that kind of spin move you see in the pelvis with a lot of your powerful players. And then we're looking at vertical force, or how much force we're producing pushing down that's propelling the player up as they're going through. So those are kind of 3 big ones that we look at. We go a lot further, though. We're going to look at really the specific timing of when those different types of forces kind of happen during the swing. And we've seen a very specific pattern where we're going to generally see that lateral force happening first, then we're going to see that rotational torque, and then we're going to see the vertical force peaking last. The other piece that we always look at in great detail is what we call point of application of that force. So we want to see where on the player's foot are they generating that line of action of the force or generating that force from, because those from a training standpoint can actually be the most important things to look at. So, if I had to give you again the 30,000-foot view, we're looking at a sequence of lateral followed by rotational torque followed by vertical force, all happening in a very short period of time during the swing. We want to make sure that the timing of those, are specific and happening before, before we're getting to impact for sure. Probably almost before like the transition of when the bat's starting down.
Yeah, for me, it's when the front heel lands, and that was going to be my next question. Is once the front heel lands and initiates the swing, how much weight's on that front foot as opposed to the back foot, or does it vary?
Nearly 100%, Tyler.
I mean, it's going to vary a little bit, but a whole lot, yes. Right? A whole lot.
And again, the other thing that I think is very interesting is the front heel tends to land, but then most of that force that happens both from a toward the plate standpoint and also up is actually coming through the ball of the lead foot. So the heel tends to land, and then the ball of the foot's actually pushing down and forward after that landing. So
similar to sprinting, right, Tyler? I mean, obviously that's with sprinters, the heel's going to contact first, and then the ball of foot's going to go, correct?
Well, and again, in sprinters, though, sprinters are a little bit of an interesting character, right, Ryan? Because they're trying to propel themselves so far forward that if they slam heel-wise, then the force is going to point backwards. So they tend to get a little bit off the heel. I think what Mike's talking about, too, with these baseball players, right, is like they slam the heel, but they're putting so much pressure for this strong ball of their foot. And as Mike brought up, it's a lot about what they can do up and down, but so much of it is also their capacity to push really hard towards the pitcher's mound, right? Which is then going to create a force that's pointed backwards. And it's interesting you mentioned the research in the baseball world and kind of where we're at. There's so much wonderful research on ground reaction forces in baseball pitchers. It sure seems like hitters is just lagging a little bit behind, right? Just a little bit behind. Again, there's good stuff out there.
Which it shouldn't, because they're both very similar. When you watch the lower half of a pitcher or an infielder throw, it's very similar to how guys hit. It's very
similar. And I wonder if partially, Ryan, because the injury bug of pitchers, kind of raise this light of like, man, we need to understand this stuff so well so that we can help pitchers reduce risk for injuries. And maybe it's like now we're just kind of spilling over into what hitters are doing.
They would just get their front foot more stable on the mound. It would clean a lot of things up.
It's funny. It's like you said, it's so similar, right? I worked with a guy in Utah who had a mound with spots in it for force plates. So he could throw force plates in there, and we could actually look at them, and they were angled the right way. And anyway, a lot of fun stuff.
And then let's get into the 3D motion stuff with biomechanics.
Sure.
Yeah, and that's where kind of Ryan, that's where I think I'm most excited. And I would actually say that I think baseball, in terms of sports, is maybe leading the way on some of this, which I think is cool, right? So traditional motion capture systems have been kind of reserved for labs like mine, person come in. I have to put all of the reflective markers and balls and dots over bony landmarks. And then it's an hour-long process to collect 10 pitches or 10 swings. And I have to go back and post-process data, build reports. And the world of biomechanics is going towards what we call markerless motion capture now. And so that can be as simple as stuff through your phone, through a tablet. A lot of baseball stadiums now are actually putting camera systems up and kind of surrounding their field. And then they're starting to build these biomechanical models, basically building a skeleton inside of these baseball players and watching what they do when they pitch, what they do when they hit. And so that's a world where I actually think, you're starting to see that a little bit in golf, but it tends to be like a single camera view. Baseball, there's stadiums with 10, 20, 30 cameras set up to try and start accurately collecting some of this motion capture data.
Hawkeye has really advanced a lot of stuff for baseball. Not even just hitting pitching, but defenders, angles, how fast they're getting the ball. Like, it's opened up a world for baseball with Hawkeye.
Yeah, and it'll be cool to see, Ryan, how that spills over into things like basketball and soccer and some things like that, where it's, like you said, the position of the player, the angles they're taking on the field, and that type of stuff. Again, data is going to take over every decision we make in sports, and if you don't get behind it, you're just going to be left behind.
So when you're looking at the 3D motion capture stuff, what sticks out as far as who has an efficient swing, who doesn't? What are the things that you're looking at with that?
Yeah, there's a lot of different things that we're really looking at for that. I think what we would call a kinematic sequence is really important to looking at a lot of this. And I mean, this goes back to, again, a lot of that research I was doing with Justin back in 2011, 12, 13. Generally speaking, just about every rotational sport, the kinematic sequence is very similar. So it's similar in golf, it's similar in tennis, it's similar in hockey, it's similar when a pitcher's throwing or an NFL quarterback's throwing as to when a baseball player's hitting a ball. We generally start to see the lower body, the pelvis, start to rotate first, accelerate first, and then we tend to see a transfer of that speed up the chain of segments of the body. And I've always liked to think of this as the next segment that's going to go is going to fire aggressively, and that's actually going to cause that segment below it to stabilize, and that stabilizing factor makes it kind of slow down. So you see this kind of series of acceleration, deceleration in every segment, even though you'd never tell a player to do that. It's more that just as that series of motion goes up the chain, one series fires after another, and the one below it needs to stabilize. So when you look at a Major League Baseball player that has a very efficient swing, you're going to see that pattern happen kind of pelvis, torso, arm, bat, right? When you see amateurs that do that, you may see them that have flaws where, we see it all the time in kids where the bat's too heavy. They're doing everything they possibly can to try to get that bat to change direction, so those segments get too spread out, and their body's way turned over here, and the bat's still way behind them because they can't get it to move. It's interesting. We actually see the opposite sometimes with collegiate softball players. There's a lot of those players that are a lot more powerful that actually sometimes need a heavier bat. So they're getting to a point where their bat's so light, they don't need to use those other segments, and they get more into those, that kind of traditional slap hitting kind of look. We're actually looking at that and saying you guys could be a lot more powerful if you actually added a little bit of resistance and got your body more involved in the swing. So, yeah, I mean, there's the full gamut of different things that you can see there. There's different kinds of variance in acceleration or deceleration. We tend to see a lot of different physical things pop up. If a player motor control wise can't rotate their lower body and upper body independently, they can have a hard time with sequencing, and that can affect timing. And yeah, I mean, again, that's another 2-day webinar I think we could go over on rotational sequencing. We actually just did one on golf and rotational sequencing a couple days ago. But yeah, I mean, there's a ton of data there. There's a ton of data there that can help make people more efficient. There's also a ton of data there that can help reduce injury risk, because you can see where players are overloading their arms or overloading their hips or things like that right away by looking at that data. So, yeah, tons there.
And I saw the puck knobs this week, and so, by the way, I don't feel as bad about, I know I said 60 ounces, but most of the weight was on the handle. So the puck knobs reminded me of the training that we were using with overloading more on the hands, not on the back end of it, on the end of it. It was more towards the hand because we felt like it showed their swing still looked fairly natural. Even though we were putting a lot of weight, it was on the handle, so their swing actually did look natural.
Yeah, this all goes back to that concept we were talking about with moment of inertia, right? And there's been a lot more research done in the last few years in baseball, starting to look at balance point and how balance point affects MOI, and how the same bat that's a 33 drop 3 bat could be very, very different than the next, right? So we just kind of took advantage of that concept when we developing the puck knob, the VELO puck, mainly because we saw a lot of Major League Baseball players doing it, and there's a ton of them out there now. I mean, you saw like the early, like your Goldsmiths and Arenados and Evan Carter were some of the early ones. This year, Stephen Kwan's like leading the league right now in average with it. Like these things are it kind of seems like it was a secret or like a cheat code for some
his powers numbers have gone up too.
Yeah, it seems like
his power numbers have gone up. Yep. And I saw the Guardians play when I was at the Division III World Series, and he was the one guy that stuck out. You could notice he was using the knob on the end of the bat.
So this all goes back to a really, really simple physics equation that Tyler can explain in more detail, but force equals mass times acceleration. Okay, we're trying to impart the most force we possibly can on that baseball and make it go as fast and as far as we possibly can. Well, you can also kind of look at acceleration as velocity squared. So how fast the bat is moving is the most important factor when it comes to creating exit velo. So anything you can do to make the bat move faster is a great thing. So what putting a puck knob on a bat does, and we found this kind of magic range of how much weight that we can put on there and how far away from the handle we extend it from the player's hands in order to actually reduce the MOI of the bat. So what that effectively does is it allows a player to swing the same bat with an overall slightly reduced MOI. So they get the same plate coverage, they get the same feel, essentially, of where the bat's going to go through the zone, but they're able to make that bat move faster, and that faster velocity ends up being more force, ends up being more exit velo.
Plus it buys you more time to react to the ball. That's the biggest one for me. Besides the ball coming off better, it buys the hitter more time to decide when they want to swing or not.
Well, and I think, Ryan, what you said there was cool. Again, I got to do some of the initial product testing at Utah Valley University, and some of the players that I worked with. Again, and I'm kind of looking at it from a golf lens initially, and I learned a lot through that process. But one of the things that stuck out to me a lot with the puck knob was the ball, how much better the ball was coming off the bat, right? You started to look at these, kind of optimal launch angles and kind of where you want that ball to be tracking. And I was using the Rapsodo device looking at some of the stuff. And it was like all of a sudden, the amount of balls that they were hitting in that kind of optimal angle that at least they were going for at Utah Valley University, and I know sometimes the coaches will be a little different at what they want that ball to do. It was like with that puck knob, that ball was just coming off at those angles over and over and over and over again. I think the sense of the hands there, like you said, the time being able to kind of get some things.
That goes into power too. If you have more time to see the ball, you're going to get better pitches to hit too. Like that's a big part of it too. It's going to come off better, but because it's giving you more time to see the ball, you're going to get much better pitches to hit because your pitch selection is going to be much better.
Yep.
Yeah. So we saw a lot of these guys doing this in the majors, right? And we're like, well, it's going to be pretty hard for every junior player to go get a custom-made puck knob bat, and they can't use wood bats in all these leagues anyway. So that's why we decided to make one that you could just put on any bat.
What are there some things that you guys believed when you first got into this that you don't believe anymore?
That's a good question. I mean, on the speed training side, like we've lived in that world for so long that like. We feel like we've researched it exhaustively to create some very efficient ways to get more bat speed. I think as we've worked with the puck knob stuff, we're finding more things that it impacts in the player's swing. Like Tyler said with launch angle, like that little bit of counterweight behind the player's hands. We're starting to see that really help players like keep the bat on plane longer through the zone and various things like that. I'd say we're starting to come across more of those pieces than anything. We're continuing to research this and do more and get as much data as we possibly can. So I'm sure there'll be some things that come out and surprise us. But, again, I think we'll see a lot more new things with the puck knobs for sure as they get more out into the market and more people are playing with them.
And I'll add, Ryan, just the idea that when we were kind of testing the puck knobs, and I got to test them on collegiate baseball players, I got to test them on some younger kids. And again, looking at the different masses and thinking about kids' bats versus pro bats and things like that. Had you asked me to begin with, I would have said, I really think the more advanced player is going to maybe handle this puck knob better. It's going to be better. And again, it's a benefit for them. We see that. We see it in these major league players. But I was really shocked in those young kids what a difference it made. And again, my hypothesis now going back would be looking at it saying, again, I think sticking some weight in those hands, they're sensing the location of stuff so much better because there's just a little bit of mass there to hang on to, and they're getting a little bit of a benefit from the torques of that counterweight. And so that was something that was a little eye-opening to me.
For me, I liked it because I felt like it got their barrel going in the correct direction. Like, I think it forced their hands to get going to the baseball in the right direction. That's the other benefit of what I felt like it did for our hitters was it allowed their hands to get going in the right direction.
Yeah, I see that especially with like junior athletes that are using a bat that may be just on the edge of being too heavy for them. Like, I feel like this can be a really good like intermediate step. Like they can throw this on there and they can still use that just slightly larger bat that gets them a little more plate coverage, but it makes it so much easier for them to get it through the zone.
What about from a data piece? Because Tyler, all data's people hear the word data and I think they get sideways with it, but all data is good data, whether it's throwing something out or affirming what you believe. All data is good, correct? It's just a matter of data's data.
Yeah, for sure. It's funny. I tell my students that a lot, Ryan, where it's like everyone's trying to look for the small p values and the statistical significance. And I'm like, hey, guys, if you try something and it doesn't work, you learned something, right? And that's been our process, especially with the weights.
The scientific method. It's called the scientific method for a reason.
Yes, you do it. And it's not about finding the thing that has to be different. It's no difference and informs you a lot. For us, I think that was a lot of the puck knob weights. As we played around with these different weights, going up to 3.5 ounces and down to an ounce, and we would do things, and I'd be like, well, that didn't work. That changed it. I thought it would work, and it didn't. And now all of a sudden we say, cool, well, that's not going to be a good weight that's going to be very good for a puck knob. So let's.
Our original design on the puck knob actually was one that had like a little disc inside that you could change how much weight was in it, and we thought it was really cool. It's actually in our patent, that we have like that type of a contraption that goes in it that you can use. We kind of found that it didn't matter. Like we found that there was this magic amount of weight that you could put around an inch. You needed about an inch of distance because the distance behind the hands matters too. Mm-hmm. But yeah, that like 2.25 ounce or so range. Again, we thought we'd get big time different results if we put in 3, 4, 5 ounces or less. And it really found that there was kind of a magic number right around 2.25 with about an inch.
Ryan, I wish you could have seen me initially doing some of this stuff because I have access to some baseball bats, but I'm like, okay, I want to find every baseball bat I can. So I'm in Dick's Sporting Goods and Shills, and I've got my computer out with my spreadsheet and the balance machine, and I'm putting different puck knobs on, and I'm calling managers at Dick's, hey, I'm going to be doing this. Are you okay with it? And they're like, yeah, you're fine. It was a cool process, like you said, using the scientific method to say, what works, what doesn't work, and ended up kind of finding some things that we felt like worked for a lot of players.
All right, everybody has to answer this question that comes on. So, do you guys have a fail forward moment? Something you thought that was going to set you back, looking now, it helped you move forward? Could be professional, could be personal. Everybody's got to answer this one question.
Okay, go for it, Tyler.
Yeah, mine's easy, right, Ryan? I wanted to do golf biomechanics, and so when I applied for PhD programs, I applied for a school at Arizona State with a guy there who did golf biomechanics. He worked with Titleist. I thought, this is it. This is where it's going to be. I applied. I didn't get accepted. I literally hadn't applied anywhere else. So I had a wife and a kid, no place to go, thinking, you got to be kidding me. And anyway, some things in Tennessee worked out. That PhD ended up being 1 year shorter, which put me at UVU, which I never would have been there had I been in the 4-year PhD at Arizona State. And now what's kind of cool, Ryan, is instead of having to work underneath someone, again, I love to collaborate, but I also like kind of being the one that gets to run the show in my own lab.
Go ahead, Mike.
Yeah, so mine's probably more of like a phone call with my parents when I told them, hey, we developed this training aid and it's just kind of getting off the ground, but I don't have time to deal with this because like I'm running this big golf academy that had like 4 locations at that point. It's like I'm just gonna move across the country so I can't teach any of these clients anymore and can focus on this. And yeah, they thought I was an absolutely crazy person at that point. So kind of turned the keys of that whole business over to a good friend that was working for us at the time and now ended up buying the company from us. Actually went from Chicago to DC for a couple years to just kind of get on an island and be able to focus on these kind of more product-based businesses. So that was definitely mine.
Any books or podcasts that people need to jump into, maybe to dive in a little bit more, or just anything, books or podcast resources for people?
My favorite stuff is all of the different, there's scholarly stuff by Dick Schmidt and a few other people on motor learning. I think at least for coaches, this is kind of a coach-centric podcast. Like if you're a coach and you haven't done a whole bunch of research on motor learning science, you are doing your players a disservice. I think that is the stuff that will help people more than anything else streamline and simplify the way you talk to players, the way you create drill programs. That stuff is my favorite that's out there.
Yeah, and again, obviously your listeners are very aware of Driveline, baseball. Obviously being a guy who loves data, I love seeing their stuff and kind of what they're doing. And what I've started to do a lot lately too, Ryan, would maybe a little bit different, is looking at more kind of body performance type podcasts, right? I think we can learn a lot from these people who specialize in getting the body to perform. And so Andy Galpin is a big name in strength conditioning now. That's kind of, he just started a new one that I've listened to and really have enjoyed the content. And so, those are some of my favorites currently.
What are some final thoughts before I let you guys go? Where can people find you, or anything else we need to talk about before I let you guys go? Yeah,
I mean, like I said, we're just, we really are just getting the ball rolling here at VELO Sports. We're really excited for a lot of the things that are coming. The Overspeed products are available in drop 3, drop 5, and fast pitch softball sizes. We have kind of planned for the future also like a drop 10 baseball set, so like a youth baseball set. That'll be coming. The puck knobs are out and available. We've got those approved for use in a number of different leagues, USSSA now, baseball and softball, a number of others. All of those are listed on our website, but that's really exciting. We're going through testing and committee for NCAA here in August, so that's coming up. You can find a whole bunch more information on all of those products and stay connected with what's coming soon on our social and then also on our website at velosports.com.
What's your social? What's your Twitter handle?
All of those are the VELO Sports.
Okay, perfect. Tyler, what about you? Final thoughts?
Yeah. Again, final thoughts. I think just we're excited about, I think, the data we're starting to collect and generate. Again, we got 20 or so players at UVU that are starting to use this now. And in fact, Ryan, because Coach Smith, I just got word from his strength and conditioning coach, and maybe you saw this, he just took a job at the University of Washington.
Good for him.
So good for him. That's where he's from, and I know the athletic director up there very well. But so maybe we'll be doing some work with the University of Washington here pretty soon as well. And so, Again, just lots of people that are excited. And I think if you're not doing this type of training now, you're just getting left behind, right? There's so much on the table to this overspeed training, getting that body to move faster. And so again, we've tried to create a really simple yet effective system and give it a look and reach out and let us know how we can help you.
Hey, by the way, people thought Bryson DeChambeau was crazy when they first saw him swing as hard as he possibly could in his
worked out well for him.
It worked out fine for him. Hey, by the way, can you guys help me with my golf swing? I need a lot of work.
I think we probably could. We can figure it
A lot of
out.
work. Awesome. Guys,
We're looking forward to seeing everybody at the ABCA convention. We're excited to be an official partner of ABCA. It's been a great organization. So, we're excited for everybody to kind of see what we're doing. We'll be doing a presentation there at the convention as well. So, we'll have a pretty big booth and hopefully have that. It'll be pretty fun for those few days, I think, in the DC area, right?
Yes, sir. Yep. And the Expo Theaters have been phenomenal here. They've done a great job with the Expo Theater. It's been good. And they're in a great spot now, too, because they're close to the main stage and the youth stage where the Expo Theaters are at now. So it's good. It's been really good. I appreciate you guys for coming on, man. This was fun for me. Appreciate it.
Yeah, thank you for having us. If if there's anything else we can answer, we had a few topics there that could have gone on for a couple more hours.
We'll have you guys back on at some point.
Thanks a lot, Ryan.
Thanks, Ryan.